So continuing with section or chapter 3, we want to take just a couple of minutes and review interpreting standard deviation. That's a fairly important concept in the course. Okay, so we talked about coefficient of variation. So make a note of that formula. Be sure that you have that down. That is used to compare two standard deviations. And decide which one is more variable or has data that's more spread out. All right, so let's do a quick example of what that would look like. All right, so the mean number of sales of cars over a 3-month period is 87 and the standard deviation is 5. All right, so we have sales. We also have commission data, and they're telling us that the mean there is 52.25 and the standard deviation is 773. And they're asking us to compare the variations of the two. So I'm going to do a coefficient of variation for each one. All right, so for the sales data, I am going to do, remember that we will have the standard deviation on the top, so we'll have 5, and the mean on the bottom, so we'll have 87. All right, and times 100, I'm going to put it in my calculator. It's a fairly easy calculation. 5.75%. All right, and then I'm going to look at the commission data. And do the same thing. So I'm going to take my standard deviation for that one, which is 773. Divide by my mean, which is 52.25, multiply by 100. All right, that gives me 14.79. So the rule here is that the bigger the standard deviation or the bigger the coefficient of variation is, that indicates that data is more spread out. So the commission data, because the 14.79 is bigger than the 5.75, this data set would be more dispersed or more spread out, however you want to look at that wording. All right, so that's an example of coefficient of variation where you are comparing two standard deviations. All right, so if you only have one standard deviation, then you're going to use Chebyshev's theorem. Okay, so remember that we have this theorem. We never wrote this theorem down, but we talked about it. We talked about linking a k value of 2 to a 75% and a k value of 3 to 88.89%. So be sure that you have that written down for Chebyshev's theorem. All right, and then let's go through an example of how this works, or maybe a couple of examples. All right, so the first example says the average number of calories in a regular sized bagel is 240. So essentially I'm going to be making a number line, and the average is going to sit in the middle. The standard deviation is 38. Find the range at which at least 75% of the data lies. So I know that because they give me 75%, that the k value is 2. And a k value of 2 means that I'm going to jump 2 spots on either side of the mean. So I'm going to go ahead and mark off 2 tick marks on either side of the mean because the k is 2. And then the standard deviation is 38. So for each of those marks, I'm going to add or subtract the 38. All right, so 240 plus 38 gives me 278. Plus 38 again gives me 316. Then I'm going to come back in the other direction and subtract. So 240 minus 38 gives me 202. Minus 38 again gives me 164. And so it's asking for a range of values. That range would go from 164 to 316. Okay, so that's one direction that you can go with the Chebyshev's problem. All right, the other way would be something like this. The average farm in the United States in 2004 contained 443 acres. Okay, so that is my mean. I'm going to put that in the middle of my number line. The standard deviation is 42. Use Chebyshev's theorem to find the percent of values that fall between, and these are the n numbers, 338 and 548. So remember, on a problem like this, we need to calculate the k value first. So I'm going to take one of those two edge numbers. It doesn't really matter which one. I'm going to take the 548 and subtract the mean. So I remember that when we did this, a lot of you had trouble because you subtracted the two values from each other, the 338 and the 548. It's going to go from the mean to either of the values. And then we're going to divide that by the standard deviation. So they told me the standard deviation was 42. Okay, so 548 minus 443 is 105. Divided by 42 is 2.5. So now what I have just done is calculated my k value. Now I need to calculate the percentage. So remember, to do the percentage, you have a formula that says 1 minus 1 over k squared. That's part of the theorem. I'm going to plug in my 2.5 for the k and work it out. And that will give me my percent. That actually gives me 84%. So you want to be sure that as you get ready to take your final, that you can do a coefficient of variation problem and that you can also do a Chebyshev's theorem problem.